experimental warning program, some of you that might not know, but we aim to issue experimental warnings on that and look at products and issue products on a warning scale and improve that prediction of those warnings in that 0 to 2 hour time frame. It's located in Norman, so we have a large group of people, scientists, operational meteorologists that surround us here in the building, and aim to serve all the Weather Service offices and CWSUs across the nation. And we consider this a vital component to the research to operations process, and I'm getting valuable feedback on some of these experimental products for them to be greater use in operations on down the line. So a little bit about where we operated this week. So these are the CWAs that we operated throughout the week. Started in Cheyenne and Lubbock, had some active weather on Tuesday and Wednesday across the Great Plains in Kansas and Oklahoma, and finished up yesterday operating in Iowa and also in Binghamton, New York, and also had a rogue forecaster that looked at some stuff out over the ocean, over the Bahamas region, looking at some of the lightning and satellite products out there.
Thank you.
As well.
We'll go and take a look at the GLM data that we looked at this week. Up here we have a 4-panel loop. It's 30 minutes of data looping, but it's 1-minute increments. In the upper left we have one of the products we're looking at, the flash extent density. Upper right would be the average flash area. Bottom right, the total energy, and then the bottom left would be half degree reflectivity of that general area of Oklahoma and Texas. And I won't go into all the nitty-gritty details of the products themselves and how they were created. That's more for the developers and the upcoming training with the SUs. But these three products seem to work pretty well from a forecast perspective of helping to give me an idea of what was going on within the atmosphere and from a lighting perspective. A little bit of going back to some of the basic training, knowing that we had the events, then groups, and then flashes. So the flash extent density was another way of displaying it. Really go and give me a good overview of what was happening for the storms in 1-minute increments. Flash area, another way of showing things, and a bit of an inverse, which I'll go over in the next minute. And then the total energy, just kind of pretty much showing the energy coming out of each lightning bolt. Mike, if you go at the next slide, and we're this is a loop that pretty much stopped at 17Z, and we're kind of go back and forth between 17 and 18Z. What I want you to kind of notice is that one cell that's pretty much at the top of the screen up in the northern part of Oklahoma. When you kind of look at the flash extent density, there's not too much with it at 17Z, but then you go and look at 18Z, kind of goes and expands outward. And then in comparison, when you look at the flash area going back and forth, there's not much to it at 17Z, but at 18Z there is something. And total energy, same thing. Once you go from 17, not much there. 18, there is something there. So pretty much what this is we have just kind of general lightning within that area, and then one large flash that's going up in the anvil. So the flash extent density at 18Z is picking up on it. The total energy really picking up on it. But then we have this, at least the flash area, inverse to it. It shows less of an area, which is, a little bit opposite what we as forecasters would think, but based on a lot of the training that will be forthcoming, it does go and make sense with a lot of the data that they're showing. So being able to really go and see this data in 1-minute increments helps out quite a bit. But what I found to be very useful, flash extent density and total energy within this GLM product. Next slide. Also go and show a quick view that we had of prob wind. Up to now we've been looking at a lot of the prob sphere products, and in this case we're able to look at prob wind increments, and it did pretty good with the tornado side and then hail side, but prob wind still needs work because I have this one example here in Binghamton from yesterday where we had roughly about 50 to 55 knots of wind velocity heading towards the radar at about 2,500 feet. But then you kind of look at the prob wind with that area, and it's only like 1% increments as we see now with the current slide. Prob wind 1%, above ground level, 2,500 feet, got 53 knots. So what happened here? We're at 1932Z. Well, at 1927, and no, this was not a tornado in that area. It's just a color scale. When we took an image, the blues turned red. But right in that general area at the bottom of the screen, 1927, in East Corning, New York, we had tree limbs and wires down on Timberline Drive. So in this case, a lot of those 50-knot wind mixed down to the ground, and pretty much the prob wind just did not pick up on it at all at 1%. So that's definitely very concerning and a problem that needs to be looked into as we continue to evolve this product going forward. So the takeaways that I had from the GLM stuff, there's definitely value within the 1-minute GLM imagery, but I would much rather, as a forecaster, have access to 5 minutes worth of data with 1-minute updates, because it can be, as you kind of saw in the brief loop that we did, very splotchy and kind of hard to tell general trends with everything. As far as like which product stood out to me the most, it was actually the flash energy product, because as a lot of the developers described to me, you're looking at GLM optical type of imagery like a high-speed camera and looking at it from almost like a light bulb perspective. What's the wattage of a light bulb, whether it's kind of on for a minute or kind of flashing each minute. Yeah, I mean, it's just easy for me to understand. So kind of going and portraying the optical/flash energy and looking at that in that product form, just very easy for me to understand as a forecaster and to pretty much see going forward trends in the storm. So I found that product to be very useful. But of course, training will be very, very important for us to understand a lot of these products, because a lot has changed since the initial training a year and a half ago. Very important for the SUs and the satellite focal points to really get a good grasp of this before it's rolled out to the field. And then to finish things up, prob wind, it did perform well in many cases, but it's still very inconsistent from what we've seen here, and absolutely should incorporate velocity and base and SRM data in it to be more effective.
All right, thank you, Michael. So next we'll have Steve Cobb.
Good afternoon, everybody. As the SU, my perspective through this experiment may have been a little different than the forecasters. I was really focusing on not only the science part of it, but the application part, and increasing my confidence that I can convey to the forecasters that I'll be training and interfacing with the value of these. This first image here we see is actually a split storm moving across the Oklahoma-Kansas border. I like this because it shows that the 2-kilometer resolution, which the developers have done a good job of downscaling from what we thought was going to be an 8 or 10 kilometer grid down to 2 kilometers. You can really see the storm scale aspects here in GLM. As Michael was saying, the 5-minute summation is good, but I also like to have the 1-minute imagery or 1-minute updates and imagery still in the menus, because over a 5-minute loop, some of the storm scale details can get overlaid with other storms or other pixels. So you really see the detail here of the individual storm scale structure. So basically over time, as the storm split, the separation between these two became apparent. Obviously, you need radar overlaid with GLM as well as other base products because of the parallax view. You can see here that there is a parallax effect, so having the radar imagery along with GLM really helps to resolve that, as this last image shows. Now, here's the 4-panel, similar to what Michael had in my upper left here is flash extent density. So that's the number of pixels that are, or number of flashes that are illuminating a certain pixel, kind of gives you an idea of flash rate. The lower left is flash, or in this case, group area. It tells you about the extent or the size of the flashes. And then the bottom right is the total energy. What's interesting about this is that you can see that the within the convective line, the flash energy is the same as it is in the anvil. That's despite the differences in flash rates and flash sizes in those two. In the flash area, I want to concentrate on that in the lower left. You can see the smaller flash sizes in the convective line, the north-south line, but the extensive anvil has much longer flash, or much larger flash sizes. Those orders in the anvil will be on the order of 1,000, 2,000 square kilometers, whereas along that convective line, the flash sizes will be much smaller, less than 100 square kilometers, more like 50 or 70 square kilometers. So you can really see the difference in the flash area between the storm scale convective line and the larger mesoscale stratiform region. So here's a prop tour 4-panel of a line of storms moving through the Wichita area. My confidence increased in the prob hail product because I think it's fairly well calibrated at this point. As Michael said, the prob wind still suffered from issues throughout the evolution of the squall line. Even though the winds were sub-severe observationally, the prob wind contours continued to be very high, 90% throughout the whole. So it didn't provide much help. But what's interesting here is you see the prob hail change at the beginning of the loop start to ramp up in size, and that gave an indication of the reintensification of this line. Also, the prob torque changed at the end of the loop because at the end of this loop there was a mesoscale or a QLCS spin-up, and the prob torque started to catch on to that increased tornado probability. So having each of these individual prob severe elements can give you information of value. The takeaways, first of all, the GLM was really, I think the scale of 2 kilometers is really good at identifying storm scale processes. We have to remember, though, we can't compare GLM to ENI directly, but they're good companion products. So you can't compare the flash rates from ENI or a ground-based network with the flash rates from GLM directly, but relative to each other, they're good companion products. The most value I found throughout the week with GLM was not one single product, but having multiple products to help that application process the application of GLM become more apparent. And then the prob severe hazards, like I say, seem pretty well calibrated, especially for the hail, and provide good awareness of the storm severity.
Thank you so much for listening in, and I'm really grateful to be here for the spring experiment. This has been a tremendous week of learning for me personally, and I'm hopeful that some of my feedback will be at least somewhat useful going forward. Having said that, I think that you know, as a broadcaster, we're looking at products that we might be able to also put on the air, and so I wanted to focus on a couple of the ones that I felt may be very helpful, and also helping share the severe weather message that you are, of course, in charge of initiating for any severe convection out there. I have 3 different forecast offices that is in my DMA, my TV viewing area, so I went a little bit rogue today. But I want to show you the week 2 haiku that I came up with, thinking about this with a more artistic approach. We also went to the Oklahoma University Museum, or the Fred Jones Jr. Museum here on OU's campus. And here's the week 2 haiku. So for those of you who love acronyms and maybe some English lit too, I thought you would get a kick out of this. New caps and CI, you are no prob severe yet, just look pretty now. And so that's really referencing a little bit about, you know, some of these products can be a little messy to begin with and maybe not as smooth as we're used to looking at, certainly for TV purposes, but also for the visual that meteorologists are really looking for. Again, those 3 different forecast offices that I am looking at and I'm in charge of translating the warning messages from are Greenville, Spartanburg, Roanoke, as well as Raleigh. And here's the 4-day panel, or excuse me, a 4-panel of Prob Severe overlaid on a product called RGB Day Cloud Convection. Now that RGB layer, that satellite layer, is super helpful, and it became one of my favorite products to use as the base layer. You're able to get a more multi-dimensional view and perspective, I believe, of the storm, and it helps your forecast thinking in that mindset. You're able to look at some of the cloud edges, cloud tops a little bit differently, and that helps you as you're putting on these other severe parameters to look at. Here we have in the upper left-hand corner, and Prob Severe is a product that's helping give us guidance on storms from 0 to 60 minutes. The Prob Tornado here up in the upper left is showing a very low probability. You can see in the grays, that legend doesn't go all the way, I think, down clearly for you, but you can see about 10% is what it's reading. Upper right panel, you've got the hail, Prob Hail. And Prob Hail here is picking up on a couple of these cells, but at this point, up in Surry County, and Stokes County is to the east, where we've got already hail in place, it's only showing us about 10 to 20%. So that storm, I believe, was already warned at this point or about to be warned, and we then had reports of quarter-size hail. So in terms of that, it would be a low reporting. The bottom left is the prob of wind. You can see here about 20-30%. We did have some wind come out of this and verify later. Not as many reports as we would anticipate with this 30% probability, possibility, or is we're looking at it. And then the lower right panel is your Prob Severe product. Overall, the Prob Severe may pick up on a little bit more, but even then it was missing some of those storms. So that gives you a view. This is the second group of 4 panels here. You're looking at a product in the purple and yellow color legend. That's our GLM product that we're analyzing. It's a total energy here. And so this has been, over the course of the week, a good product, I believe, to use to look at how storms may be intensifying. And you're looking in the upper left panel. I've overlaid it with velocity to show total energy in Prob Tornado. I just wanted to see also at the surface what was happening with that. And you can see that gray outline over top of the GLM showing you still a low percentage. To the right, the upper right panel, you've got your reflectivity on the bottom. You've got your GLM in the purple, yellow, orangish color bank there. That's showing you the GLM, and the brighter, whiter, yellowish colors are the, I guess, the greater total energy. So that color bank isn't up for the GLM. I've got the Prob Severe color bank up. And that Prob Severe at that point is showing for hail a much better signature. But keep in mind, this is the line of storms that's already moved through Surry County. So it does catch up, but it takes a long time. And this is like a 2021Z look for that upper right panel, as well as all this 4 panel that is the same time frame. Total energy and prob wind on the lower left. We've got a higher percentage, and that storm did end up verifying. I was working with Tom that day, and he's going to have much more on that. But total energy and Prob Severe on the bottom, also now picking up for this group that's in the Raleigh warning area. But the storms overall, just I would say that these products are sluggish, that Prob Severe has a little ways to go in terms of my being comfortable using the indicators, but I think that this will be a super helpful product for us going forward, also as a visual to the viewers. It may show trends potentially where those areas were outlined. The RGB cloud products were fantastic, or excuse me, satellite image products I thought were fantastic, not only from a pre-convective forecasting standpoint, but also potentially for on-air use. So the Prob Wind and Prob Hail both seem sluggish. I think that this is a good product, needs a little bit more work. The GLM Lightning Total Energy, most applicable for a quick identification of a storm intensification, specifically for forecasters who are on the air. I think that you need a quick glance. You don't have time to do all the analysis while you're also speaking. So I think that this has been proven so far, at least in this short-term week, to be very useful in that sense. RGB products also can be helpful, especially the nighttime physics, potentially in North Carolina, as we've got fog and other surface features to be identifying that might be difficult on other satellite images. And so overall, with that use, we want to also think about the use of social media as well as the web as areas that broadcast meteorologists and that you folks from your weather or service offices may be exploring even more, that people want the science and the data there from the Hearst research that's being done. Some of it's proprietary, but basically they're willing to look at some of this data with us. And so I think all of what we've looked at today can be super helpful going forward, either online or possibly on the air as well. Thank you.
Yes, so this is Stephen Latimer. I actually have a photo up there of candy, and that's mainly because I am actually going to show you guys some eye candy that in the next following couple of slides. The first one I'm going to show you is actually simple water vapor RGB, something that all the offices have available to them, and something that I'll encourage you to actually look at in conjunction with a quick guide. From what you're seeing here, there's actually ample moisture coming over the LBF area. It's actually North Platte's forecast area. I'll point it out here. This is North Platte's area here. So this is actually the area, one of the areas that we were looking at yesterday for severe convection. And so what I was looking at here was actually those blue colors are actually showing ample moisture for convective initiation. I won't get into a lot of the color tables you're seeing here, but that's pretty much what we were looking at. And the other thing that I was looking at too was a new cap sounding over eastern Wyoming. One of the things that is nice is that we are testing really new experimental types of data. New cap soundings are available operationally, but not as high latency in terms of time. So what we've got to test here was new cap soundings that were actually in much greater or much increased time latency. So what we've got here, I wanted to compare new cap soundings to see how the sounding was resolving upper to mid-level moisture compared to the simple water vapor RGB. So there is a lot of question marks here, but it's something I was trying to figure out how well it's doing. And so I started thinking about what the simple water vapor RGB might be showing. So from what I could tell, it is showing a pretty good signal for upper and mid-level water vapor in terms of saturation. I did also look at NAM12 soundings. I don't have that shown here, but it did. The new cap soundings did do better than the NAM12, capturing moisture. Maybe useful to look at surrounding new cap soundings from other points. Didn't really have time to do that, and look at the temporal trends. Developers and even further test beds may actually want to look at this further as well. The next slide I've got up here is actually a supercell split that we noticed over the western portion of North Platte's forecast area. It occurred yesterday afternoon. That would be on May 10th. So we got 2 4-panels going here. The first 4-panel on your left, this one actually has prob severe up here, your top left. Top right, prob tour up here. Prob wind is bottom right. Prob hail is in the bottom left in these little circled areas here. And that's overlaid on top of MRMS composite reflectivity. I also have some severe warnings on there as well. So that's pretty much that 4-panel. You'll notice there's a supercell split that occurs. And I was wanting to point out that we actually had pretty good signal with the prob wind and the prob hail splitting. When those cells split, it captured the 2 individual updrafts really well as they trended up. And both cells actually were severe during that time frame. Prob tour, on the other hand, remains a little bit of a mystery to us, in particular me as well. We were seeing probabilities that were like 10 to 30%, but not exactly sure how that is to be interpreted, whether we need a warning on something or what we need to look at. So still something to continue to investigate. On the right side, on the other 4-panel, I'll go over here and point this out. This image here is flash density up in the top left, and the top right is flash area overlaid with NLDN, cloud to ground lightning. In bottom right, you have total power, and on bottom left, you have ENTLN data as well. I would note that I put the ENTLN data and the NLDN data on there more as a calibration for the GLM data that I'm showing. So the flash density up in the top left, as well as the bottom right, the total power, we're really showing a really good trend as we were looking at this storm split taking place. And also flash area was also showing some really good data, but that may be more for IDSS purposes and as opposed to warning decision. So some takeaways. I encourage everyone to investigate the RGBs. Even if they look different from how you visualize meteorology, make sure to investigate those because it is really valuable, especially as we're looking at it. Quick guides help. NewCap sounding data has been very good at resolving mid to high levels. Good tool for pre-convective initiation. Some of the GLM data are valuable in warning operations, like I mentioned, flash density and total power, good for that. IDSS purposes, perhaps for the average area. Severe products are good for situational awareness and storm evolution trends. They do need some work on the color tables. Also, be willing to come to Hazardous Weather Testbed. It's quite intensive with many products to test, but it's definitely worth it. We get to be involved with the product developers. They get to see what we're looking at, and we also can be helpful in steering the training on what it's going to be like when it becomes operational. Thank you.
Hello, everybody. Being out in a Western office in Nevada, I was pretty excited to come to this hazardous weather testbed training. Definitely wanted to learn the new ways we can incorporate GOES satellite data and tools in areas where we have sparse to no radar coverage, which a large area of our CWA has zero radar coverage. So I definitely think some of these new products could be beneficial in the future. Two of the products that we looked at this week were the CI and severe CI, as well as the GLM data. First off, I'll start with the CI, which is convective initiation, and severe CI, which is severe convective initiation. Generally, the CI is saying it's going to be any convection within the next 2 hours, percentage of convection within the next 2 hours, whereas severe CI is the percentage of that convection, percentage of convection turning severe within the next 0 to 2 hours. So initially, coming into this, I kind of had high hopes for these products, but I definitely had mixed results at best using these products this week. It really seemed to struggle the first few days of the test bed. Found the product to be a bit noisy, as you can see in the loops there. A lot of jumping around in numbers there. Yeah, so values would jump real high, down to real low, back up to real high pretty quick. So, and it really struggles in areas of cirrus contamination. It does not resolve anything under cirrus that well. So, in fact, I completely missed the supercell at Stretch Across southern Wisconsin. It failed to have any sort of value on that before the initiation. So it did, however, do a little bit better yesterday with the convection detection over Wyoming and Nebraska. In this example here, over Nebraska, didn't necessarily detect a single cloud element that developed, but it kind of gave the general area of convective development that it was suspecting in the next few hours, as you can see with the cumulonimbus blow up over Cherry County in north central Nebraska. So one big issue with this is that while you can see on the right, some of the severe CI values really jump up high into the 70, 80, 90% values, whereas at the same time on the CI values, it's only showing 20, 30, 40% values. So it kind of seems counterintuitive that it thinks it's only going to be a 30% chance of convective initiation, but somehow it's going to be an 80% chance of severe convective initiation. So I think it's a product that definitely needs to be improved on for applicable. So then the second product that we used heavily this week was the GOES GLM data. So at first I was a bit skeptical of the GLM data since we already have a wide slew of lightning data to use in AWIPS, but as the week progressed, I began to see more and more benefits of using that over traditional lightning information we have. One case that we looked at were thunderstorms that moved over northern Indiana, southern Michigan on the 9th of May. We noticed that in the event density and the total energy, we noticed these sharp upticks in values of those products. And that seems to correspond with updraft intensifying in the stronger storms. And as you see, we issued a few warnings based off that. The radar data in and of itself was pretty good on these storms, but that kind of gave us that extra bit of confidence that, okay, these storms are rapidly intensifying. You know, we should probably definitely get some warnings out on these right now. And actually looking back at what they did in that office there, we kind of lined up pretty well with our warnings that they issued. So, definitely looks like it can be a benefit. So just a couple of takeaways. The convective initiation, severe convective initiation probabilities could be useful for highlighting initial storm initiation, but it's far from a finished product. GLM, definitely useful in identifying areas of stronger updraft and storm intensification. And the GLM could complement current AWIPS lightning data, but be careful as there is a parallax issue with that, with the GLM data being offset from the ground strikes and radar due to the viewing angle from the GOES satellite. So,
thank you for joining us here. One thing unique about being here is we get to play with some of the latest tools, the polar orbiting satellite, still continuing working with the GOES imagery, and then integrating those things into kind of a pseudo warning environment, and that's what we were doing today, and trying to see how we can use these new technologies and pulling this into the operations warning environment. Going to this first slide now is one things to point out is the strong updraft that we have right in this area here. This is the, let me go through real quick. This is the minus 20 isothermal reflectivity. We're getting 50 to 60 dBZs already up through that layer. There were some warnings out already for this storm. And then as we go over to the upper right here, we see the total energy. This is basically your reflection back from the lightning back towards the camera. And it's showing some high values that are right in through here. And then this down here is your flash extent density. Basically, in these brighter colors, that's just showing that each pixel has numerous high number of flashes going across each pixel, and those are being recorded and counted there. And then as we go down to the average flash area, basically, it is quantitatively is basically that flash generates how much of an area. Like for this example, here's a flash right down in this area. What I found unique about the 4-panel is I was trying to create some situational awareness tools that during the warning process, a forecaster can look at this strong updraft, which is producing a lot of lightning, which is very expected of a strong updraft. And then as we went on in this event, right in through here, we got reports, especially on this storm, just a little bit later, reports of 1.75-inch hail and some tree damage from this system. Another thing to note is back in this region here is the stratiform anvil precipitation. This is just the area of one flash, so you can see how big of an area up in that anvil top that is being related to some of these flashes. Going on to the next slide, the other thing that I put together and was looking at is some more situational pre-convective awareness type of tools, and up in this the upper right, upper left, I mean, is your K index, and then over here is your lifted index. And two notable areas here over the Sioux Falls area, they had this line of instability right into here, and then there was another secondary line of instability right in through this area here, and then this corresponds with the cape in this area and the cape down in here. And then comparing that back to the RAP cape modeling, it was indicating a very similar area of higher cape values, and then going back down towards the into Iowa, there was another second area that's a little bit further south. You could see that the All Sky Labs products have it a little bit further north, and as it turns out, a few hours after these images were taken, quite a few storms developed and blew up over the eastern parts of the FSD, the Sioux Falls area, and they had one tornado report. So I've just found some usefulness for situational awareness. Okay, my takeaways. I did find the GLM Lightning products are proving to be promising, especially if you integrate them in with some of the other tools that we have for creating a situational awareness assessment tool. Same thing with the All Sky Labs products. Again, I like being able to see pre-convectively how well things were beginning to stack up, like moisture, instability. In several of those cases, the storms that we saw during the week were moving into those areas of higher cape, higher moisture. Gave us more confidence on our forecast and what we were going to be projecting into the future for those forecast periods. And then additional research testing at the hazardous weather testbed and training. All of these products, I think, are just going to become richer, become more effective for us in weather operations.
Well, good afternoon. First slide that I wanted to do, I wanted to show here was talk about the GLM a little bit and the ability to sort of discriminate anvil lightning from the other various forms of lightning. The GLM does show the aerial extent of lightning better than the ground-based networks such as the Earth networks or NLDN. Whereas the surface-based networks, they show points and not the aerial extent. So the way that we've been trained, in my career over the last 15 years, one flash, 1 point versus several pixels possible in the GLM data. So it's sort of a different perspective, a new paradigm for viewing this data. But in this particular slide, I've got the Earth networks data up in the upper left, and in the upper right, we have it's called flash extent density. You can sort of see the aerial coverage of the particular lightning strike, which is actually extending a good couple of counties north of the cluster of lightning. In the lower left-hand corner is the average flash area, and you notice the very high values, which can show the size of the flash. And in this case, this is sort of a good indication of anvil lightning, which is extending, again, much farther north than the cluster of lightning that you see in the upper left-hand corner that we're used to looking at. And I find this to be particularly useful for IDSS purposes, where we've got maybe responders out in the field or there's events going on, and we can sort of judge that aerial extent a little better than what we could with the point data. Go ahead, Mike. The second slide here is a way to view the lightning trends. We can always run through the lightning, the flash extent display on the GLM there. We can run through the density there and loop it, and we can sort of gain a trend from it. But using the tracking meteogram tool, I was able to create the trend table over on the right, and we've got several different fields that are not shown on the particular image on the left. But it's a good way to visualize lightning jumps, detect when the lightning really begins to taper off. as opposed to going through a loop and trying to kind of quantify it in your head as it moves through time. This does it for you. The third slide here, the GLM data, like other lightning data, does provide a sort of a lead time when it comes to developing convection. In this case, we've got convection developing aloft to the south of the main line there, and we can really see a jump on the right side of the flash extent density. And that occurs well before the core develops in the lower levels. So that gives us an additional 5 to 10 minutes of lead time here before we begin to experience the stronger convection at the surface. And finally, I want to talk about the parallax issues that we have with the GLM data. Of course, farther north, farther west you get away from GO16, the more pronounced it will be. But in this particular case, the yellow lines indicate the CWA boundaries. And you notice in the upper left-hand corner, the flash extent density, as well as the other products, do extend across the CWA border into the Amarillo forecast area. Whereas if you look at the point data in the lower right, it's displaced a good 15 to 20 miles to the southeast. So that's going to be something to keep in mind, when you're talking about lightning entering a certain perimeter, maybe to an event or a venue where you have notification purposes for IDSS. But and you also want to keep in mind that flash extent density may actually be accurate, but the Earth Networks data is got to put that point somewhere instead of representing it as an aerial coverage. But the parallax issue is something that you need to keep in mind when you're looking at the data. So my takeaways from this week, the various GLM products really do help you see the aerial extent of the lightning data far better than the ground networks. I mean, we can always kind of visualize the point data and sort of draw contours around it, but the GLM data kind of does that for you, and it's just one less thing that you really have to worry about. It's a quick overview. We noticed increases in flash extent density prior to the intensification of thunderstorms in the low levels as the core was developing aloft, and we begin to see the discharge. That gave us a little bit of lead time there. And don't forget to account for the parallax error when you're looking at the data.
And then last but not least, I thought I'd show some eye candy from my home CWA from yesterday. This is actually GLM flash extent density along with prob severe, which shows up a little later in the loop on a 1 minute goes visible satellite imagery, and you can just see how the GLM data matches up very well. Increases in flash extent density match up very well with high prob severe values. Basically on that color curve, anything pink is 70% or higher, suggesting a likely severe thunderstorm. And sure enough, this thing had very high values of prob wind. The prob wind was basically 70% or higher for the life of this storm as it tracked towards the Twin Cities and did quite a bit of wind damage all on its path.
Next slide. Social media. I went for it, asked for permission to use GLM data. I noticed there was a complex of storms moving towards the Boston area where the HRRR didn't pick up on it too well. So I wanted to give that information out to the public, and at this time, that snapshot, I had 2 likes, but I did get 1 comment. What does this mean? So as the broadcast met, I'm still trying to figure out how do I explain it simply. How could I use it on television? Because I think it's a phenomenal product to show you that we can get a bolt from the blue. And then I looked at the data of cloud-to-ground lightning as well as those storms moved through Boston and towards the South Shore. We did have, on average, maybe 5 lightning strikes every 10 minutes or so. But it correlated with the highest areas of storm power, as you see on the bottom left. So I was very impressed with the GLM data. I can't wait to use it. So some takeaways here. The CI info, pretty useful. When used over visible imagery, probabilities again stayed below 50% for most of our scenarios in our case. Severe CI always low throughout the week, so I really didn't pay a lot of attention to that product. But I think it would be a good decision-making tool when I'm sitting there babysitting the radar, even in a nighttime situation at midnight, and my crew is saying, can I leave? Are we going to get convection? Well, they wouldn't use the term convection. Are we going to get bad storms? Do we need to stick around and do a severe weather cut-in? And this could really just be another tool in our arsenal to use to make a decision. Yeah, you guys can leave. Don't see a lot of probability. GLM data can be useful, easy to share. Social media on TV still needs a little smoothing, but can really alert the public to where the danger is ahead of the storm.
Yeah, the first issue I wanted to discuss is the parallax issue. This is from a cluster of storms in southwestern Minnesota. On the top left, you see MRMS reflectivity at lower levels. On the top right, you see GOES at 16, channel 13 IR. On the bottom left, you see GLM flash extent density. And on the bottom right, you see GLM event density. So due to the parallax issue, the satellite image and the GLM data are offset to the north from the reflectivity by as much as half a county to a county, which is obviously going to be an issue. So with increased temporal and aerial resolution associated with GOES 16, this is going to be even more noticeable. So this is something forecasters across the northern United States and even the western United States will need to consider when using the data for warning consideration purposes. They might actually be looking at data for a storm that they're not really concentrating on, that they wanted to concentrate on. Some other parallax questions that I actually kind of have, since the satellite and the GLM are kind of sampling storms from the side, how does parallax affect convective initiation and severe convective initiation probability products? How does parallax affect other data like GLM total energy? Does parallax affect the amount of lightning we will see in storms across the north and west? If so, how is this going to affect lightning jump thresholds across the north and west? I don't know. These are certainly areas that need to be explored, I think, before I would use these data with any confidence across the northern portion and western portion of the United States. So just some takeaways. If you're across the north and western portion of the United States, certainly be aware of parallax issues with GOES 16 and GLM data. You have to make sure that they correspond with what storm you're actually forecasting for or warning for. GLM data is certainly useful for monitoring the thunderstorms over the oceans, as we've seen. It would be good to overlay those, certainly, on satellite images.